Hello ladies and gents, we're back with another video about functions. We're still on the topic of is it a function, and specifically we're going to be looking at graphs today. So let's just revisit our definition. A function is a relationship between two sets x and y in which each value of x is matched to one and only one value of y. Again, this is the part of the definition that we are focusing on. So if I gave you the equation y equals 3x minus 1, we can graph that. Okay? And if I were to ask you, is this a function? Well, we got to approach this a bit differently. Right? So if I look at all of my x values, so let's say, right, this is the x-axis. Let's say I am looking at the x value of 0. So actually, we can write a table. This might be helpful. If I input the value of 0, really the question is, what is my y value going to be in this graph? Now, one way we can do this is we can input the value of 0 into this equation, and it will output the value of y. But I want to do this graphically. So if I input the value of 0, it's going to output the value of negative 1. Let's do another one. If I input the value of 1, it's going to output the value of 2. If I input the value of 2, it's going to output the value of 5. And if you notice that no matter what value I choose on the x-axis, let's say I choose this one, it goes all the way down, it's only going to touch this line once. So does this happen to be a function? Yes, because all the value of x's that I can put into this function, or rather this equation, will only output one value of y. Let's look at another example, but sometimes when we graph, sometimes it's a little bit more challenging. So there's kind of a trick that helps us make it a little bit easier to figure out if a graph is a function. And this is called the vertical line test. The vertical line test is a quick way to check to see if a graph is a function. All you need to do is move a vertical line across your graph, and if your line touches the graph in at least two places, it is not a function. Okay, so for example, if I gave you this function, rather, shouldn't have said it was a function, spoiler alert, but if I were to give you this graph, and I ask you, is it a function? It might get a little annoying saying, okay, if the value of x is like 1, it's this value, and like to go through all these points, it's kind of a little frustrating. So there's an easier way. Sometimes you can take your pencil, you can take your calculator, you can take anything that's a straight edge, essentially. I'm going to use this red stick. And if you move the red stick across the graph, you'll know that this red stick will always touch this graph only at one point. So for example, if I move it right here, right? Let's say I move my line and I keep it right there. This line only touches the graph right there. Right? And if I were to move this, let's say, randomly over here, this line only touches the graph right there. Since our vertical line only touches our graph at one point always, if this is a function, is this a function? The answer is yes. Okay? So let's do another example. Using the vertical line test, is this a function? This happens to be the graph of x squared minus 2. So we're going to use our vertical line test. Again, I'm going to move my vertical line horizontally through the graph. Okay. It seems that everywhere that my vertical line touches, it only touches it at one point. So is this a function? Well, my answer is going to be yes. Okay. Let's move on. Let's use the vertical line test. Is this a function? So, again, you can use the whole idea of testing different points, but it's just way easier to use our vertical line. Moving our vertical line through. Oh! What happened? Well, it seems that this vertical line touches the graph here and here. That's 2 points it touches the graph. So is it a function? No, it's not a function. So what if we want to state a value of x to show that it's not a function? So I'm going to move all of this out of the way. Actually, let me undo a couple of things just to make it a little bit more clean. So again, we said that, is it a function? No, it's not a function. So what is the value of x to prove that this is not a function? So there's many points we can choose, but let's say we choose this one. Okay, so for the x value of 1, so if x is 1, then our y values happen to be positive 1 and negative 1. So the value of x being 1 basically proves that this is also not a function. All right, so let's do a Regents question. Usually Regents questions, they mix a lot of the different representations together, so I guess it's good practice. Which representations are functions? So this one's asking which are functions. So remember, if the x values repeat, it's not a function. So 2, 3, 4, 5, positive 2. So check this out. When you input the value of 2, you get negative 6. When you invert the when you input the value of 2 here, it gives you positive 6. These are different values, so this one is not a function. Okay? Let's look at this one. Let's look at our x values 1, 2, 3, 4, 5, 6, 7. Is this a function? Yes, it is a function because none of the x values repeat. Let's look at 3. It's a graph. Now, eventually you should be able to see this visually, but again, when in doubt, use the vertical line test. So, let's move this forward. If I move this through, I can see that this touches the graph in 2 places, right there and there. So is this a function? No, this is not a function. No. So the last one we have to check is number 4. Now, y equals 2x plus 1. There's a couple ways to do this. Number 1, you can graph it by hand, but that's going to take a long time. Number 2, you can recognize that this is a linear function, which happens to be something that looks similar to this. It's a line. Or the last thing that you can do is use your graphing calculator and then use the vertical line test. So very easy way to do this. You click on y equals, because you want to plot your graph. And our function was y equals 2x plus 1. So y equals 2x plus 1. Okay, I want you to be able to see everything. Then we're going to click graph. Let's see what happens. Boom! It's a line. So if you use your vertical line test, you'll see that no matter where you have a vertical line, it will only touch this once. So, is this a function? Yes, that is a function. Let's go back to here so you can see everything. So, yes, this is a function. And remember, this question was asking which one are functions. Well, it's only number 4, so it's number 4 and number 2. Which answer choice is that? 4 and 2, right here. So, in summary, if you're given a graph and you want to know if it's a function or not, you're going to use your vertical line. If the vertical line touches the graph in 2 spots, it is not a function. I hope this was helpful, and I hope you have a great rest of your day. See you later.